Okay, we are back. So this is the portion of the notes where we're going to talk about percent composition. Percent composition is going to be how much of a part of a substance we have compared to the entire substance. So there will be times where we'll need to know like how much hydrogen we have in H2O, like percentage wise. We can calculate the percentage of a specific element's mass compared to the whole mass of the whole element using the formula below or at the bottom of the screen. So percent comp is equal to the molar mass of the element in the compound that we're looking for. So again, let's say I wanted to know what the percent composition of hydrogen is in H2O. Who knows? So we could calculate this by taking the molar mass of the element within the compound, which in this case would be 2.0 grams per mole. Why 2.0? Because hydrogen's mass is 1.0, but there are two of them, so we've got to take it times 2. So that would be 2.0 grams per mole. Then we're going to take 2.0 divided by the mass of the whole compound, which for H2O is 18.0 grams per mole. Why 18? Because hydrogen has 2 grams per mole because there's 2 of them with 1 gram each, and oxygen has a molar mass of 16.0 grams per mole. So we were really looking at the whole thing as a whole. So 16.0 plus 1.0 plus 1.0 is 18.0 for our molar mass of the whole compound for water, just one of them. And so what we're going to do to find the percent comp would be to take 2 divided by 18 times 100. I'm not going to do that at the moment because we are about to jump into some problems where we're just going to figure out the percent composition of a couple of different elements within the compound. Now, one thing I do want to talk about real quick is sometimes it just says calculate the percent comp of, and then it gives you a compound. That means it wants you to calculate the percent of every single one of the elements in the compound. And so it might sound a little scary, but if there's only 2, it's pretty actually straightforward. And in fact, let's just go ahead and solve for hydrogen and water real quick. So 2 divided by 18 is 1.111111 times 100 would be 11%. So we're looking at 2 sig figs. 11% of H2O is hydrogen. Now, we could do this entire process again, calculate the, we should know the mass of the whole molar mass of the whole compound, and then oxygen's a little bit easier because there's only one of them, so it'd be 16 divided by 18. Or if it's a percentage of hydrogen in H2O, all percentages should end up adding up to 100 if you're adding up pieces of the puzzle. So in this quote unquote puzzle, there are only 2 pieces: how much hydrogen, how much of the molecule is made up of hydrogen, and how much of the molecule is made up of oxygen. So again, we could go back and do 16.0 divided by 18, or we could just say 100 minus 11 is 89. So we know that 89% of H2O, that's fine. H2O is oxygen. Okay, because again, 89 plus 11 equals 100. That means that we have the whole compound's molar mass. Never ever should we ever have something that adds up to less than 100 or over 100 when we're talking about percent comp, because again, it's talking about how much of an element we have in that compound. All of our elements' molar masses should add up to the whole compound's mass. So again, never should we have anything under 100 or less than over 100. Okay, so we are going to go ahead and start working on some problems. Again, I just kind of wanted to talk about what you might see in the upcoming problems because there's going to be some that don't specify what element, so they want all of the elements. And you can cheat the system a little bit as long as you know all of them but one. Then you can all of them, but all of the elements percentages except for one. Then you can kind of take it out of 100 and see what's left, and that'll give you your percentage of your final / remaining element that you're looking for the percent comp of. So I feel like I just rambled on a little bit too much. Let's move on to the next slide, which is the start of our problems. Oops, sorry. Actually, I kind of gave us a guide here. Problems 4 through 7. These are the 3 steps we're going to take. You're going to take the total mass of the element that we're looking at divided by the molar mass of the entire compound. That's a weird step. Oh, okay, I'm sorry. What I was saying is to find the total molar mass versus the molar mass of the compound, you're going to divide the mass of each element by the total mass of the compound. So number 1 isn't a step, it's just what the goal is. Number 2 is the first thing that we're going to do. Divide the mass of each element by the total mass of the compound. Then the second thing we're going to do is multiply by 100 to get a percentage. That should, again, give us what we're trying to find, which is number 1. So in problems 4 through 7, steps 2 and 3 are going to be our main things because we're trying to find the molar mass of the compound. 8 and 9 are going to be a little bit different because it gives us the mass. We're still going to do it very similarly. We're going to find the molar mass of each element, find the molar mass of the compound, use the percent composition, and multiply the percent composition by the given amount of grams to get the ratio of grams in the overall mass. And again, I feel like this is a lot of talking. I feel like when we get to the problems, I'll be better at physically showing you guys how to work through a problem like this. So again, let's go ahead and get started with 4 through 7. I might go a little quickly on this. As I said in the last video, please feel free to pause what I'm saying and either work through it yourself or pause and rewind because I am, again, going to go a little bit speedy. I don't want to lose you, but the beauty of technology is that you do get to control the speed either by pausing it or I think you can just go into the speed settings and slow me down to 0.5. Although I might sound a little wild. I don't know. Maybe I'd sound normal. Who knows? Try it and see what happens. That sounded threatening. Try it and tell me what happens. All right. Number 4, a 9.03 gram piece of magnesium combines completely with a 3.4 gram of nitrogen to form a compound. What is the percent composition of this compound? So, percent comp, we're going to say we know that 9.03 grams of it is magnesium. We know that 3.48 grams of it is nitrogen. The total overall composition of the new compound is going to be the combination of those two things. So the total of our compound is going to be 9.03 plus 3.48, giving us 12.51. So grams for our total overall mass. Now we can use our actual mass of nitrogen. We wouldn't even have to use our molar mass. We can use our actual mass of nitrogen and magnesium. And in fact, I'm going to use magnesium first because it's here. So now that we found the total mass, we're going to take magnesium's mass. Over the mass of the entire compound itself. So 12.5, what did I say, 1? Yeah, 12.51 grams. Okay, Also multiply by 100 because we want this to be a percentage. And this should give us our percent comp. So 9.03 divided by 12.51 times 100 is 72.2. Again, 3 sig figs because our numerator has 3 sig figs while our denominator has 4. So we're going to go with 3 sig figs. 72.7 would be how much magnesium is in this compound. Now, there are 2 ways we can go about solving for nitrogen. We can either come back in and instead of having 9.03, we can insert 3.48 grams instead of 9.03. So it'll be 3.48 divided by 12.51 grams and then times 100, and that would give you a percentage. But to save us a little bit of division and multiplication and overall in general headache, in my opinion, we're just going to say if 72.2% of it is magnesium, that means the rest of this compound has to be nitrogen. So we're going to say 100 minus 72.2 is 27. So if 72.2% of it is magnesium, 27.8 has to be nitrogen because these 2 percentages added together need to be 100. Okay, if we did add these 2 together, 2 plus 8 is 0, carry the 1. That gives us another 0, carry the 1. That gives us 10, aka 100%, which is exactly what we're looking for. Do we need to do the double checking of the 100%, especially if we subtracted 72 from 100? No, but I don't know. I'm a very big proponent of double checking yourself just in case. And especially because I am not using a calculator at the moment. So I definitely wanted to go back and double check my mental math there. So again, our answer would be, what is the percent composition of this compound? The percent comp would be 72% magnesium, 27.8% nitrogen. So it's very magnesium heavy and just a little bit of nitrogen, which kind of makes sense with the grams, but not always because different elements have different molar masses. So you can't always take that into account. Sometimes it only takes a little bit because something has such a large molar mass to overcome something that may have a bunch when it has a smaller molar mass. Doesn't really matter. You'll end up finding those patterns out as we go, hopefully, fingers crossed. All right, so I'm going to move on to the next one. So this might be a good place to maybe pause, try to work out the next problem on your own, and then get back to it. So again, feel free to pause, but I'm going to continue going with question number 5. So this one says, when a 4.2 gram sample of mercury 2 oxide decomposes into its elements after being heater, which I apparently made this slide when I was crazy, after being heated, 13.2 grams of mercury are produced. What is the percent composition of this compound? So if we heat mercury oxide, it looks like what happens is the mercury and the oxygen separate. The oxygen floats off into the universe. We can't really measure the weight because oxygen is a gas and floats off. But what we can measure is the mercury left behind that has no oxygen attached to it anymore. So we know after heating the sample and driving off all the oxygen that out of the 14.2 grams, 13.2 of it's mercury. So again, we're going to take the mass of our, oh no, I did not mean to hit that. Please stop. Okay, we're going to take the mass of our mercury, 13.2 grams of mercury, over our mass of the total compound, which in this case is mercury 2 oxide, HGO. HGO, yo. Okay, so then we're going to do these two numbers divided by each other times 100, again, to see how much of our compound is actually mercury. It feels like it's probably going to be a pretty high number because 13 out of 14 is a pretty close to perfect, if I do say so. And we end up getting 93.0 if we round to the correct amount of significant figures, 93.0 for our percentage of mercury. Now, again, we could do this one of two ways. We could say that there's 10 grams of oxygen that got driven off because it got 10 grams lighter, or we could just say, and then divide it by 14.2, or we could just say if 93% of it's mercury, that means the other 7% has to be oxygen. And so that's how we would solve problem number 5. So again, we would need both of those numbers for our answer because it doesn't specifically ask for just the percent composition of oxygen or just the percent composition of mercury. It wants to know the entire compound. So how much of it's mercury, how much of it's oxygen. And again, there isn't going to be a random compound in there. There could be third and fourth elements, but they will tell you. It'll never be a surprise. It won't just be like, oh, these two things don't add up. It will always add up. Okay, moving on to the next one. Calculate the percent composition of carbon monoxide. I don't even know what NH2 is. That's a nutso compound, but we can do it together. So I want to know, it doesn't give us grams. So what we're going to do is, again, use molar mass, because we can assume that if we have 1 mole of the substance, then we'll have 1 mole of carbon, 1 mole of oxygen, technically 2 moles of nitrogen and 4 moles of hydrogen. But yeah, we get to use molar mass if the mass isn't given to us. So know that you can use the molar mass pulled off the periodic table. So carbon's molar mass is 12 point. Marking. There we go. Carbon's molar mass is 12.0. Oxygen's molar mass, 16.0. Nitrogen's molar mass is 14.0, but this 2 is going to get distributed because we're saying there are 2 NH2s, which means that we have 2 nitrogens. And then for our hydrogens, its mass is 1.0, but again, distributing that 2. If I have 2 NH2s, that means I have a total of 4 hydrogens, right? 2 NH2s, 2 NH2s. I have 2 nitrogens, 4 hydrogens. Okie dokie. So let's do a little bit of math here. We've got 12 to figure out the overall mass of our entire compound. So 12 plus 16 plus 28 plus, missing my decimal point, plus 4. Again, 12. Wow, it's a really small decimal point. These are all really small decimal points. Holy moly. Sorry if you're having trouble seeing them, but I promise they're there. 12 plus 16 plus 28 plus 4 is giving 60. No, that tracks. So our total mass, technically it's molar mass, right? Molar mass, but I'm not really worried about the molar mass because we're comparing all of the molar masses together anyway. So the total mass is going to equal 60 grams per mole, while all of these are also grams per mole because they're molar mass. Okay, and in order to find percent comp, remember we're going to take the amount of our element over the entire compound. So 12 over 60, 16 over 60, 28 over 60, 4 over 60. Again, if you didn't like doing one of these, sorry, 60.0 technically. Horrible significant figure tracker I am. Also, I don't have units for any of these. I'm going to be a little lazy and just draw an arrow because they all have the same units, which are going to end up canceling so that we can end up having a percentage sign in the end. Okay, what I was saying before I forgot that I didn't do sig figure units is we don't have to do all 4 because we could stop, add up all of them, and like 3 of them, and then subtract those 3 out from 100, and whatever's remaining would be our final percentage. But what I'm going to do this time is just straight up do all of them, and then I'm going to add them together to see if it actually equals 100, because again, that is the goal. So 12 divided by 60 is up first, and we get 20.0% exactly. What a nice, wonderful percentage. Then we're going to do 16 divided by 60. Not as lovely. We end up getting 26.7%. Also, I forgot to write times 100 on all of these. That's how we get the percentages. So when you take 12 divided by 60, it's not 20. It's actually 0.2. You've got to multiply it by 100 to get to 20%. Okay, moving on. 28 divided by 60 times 100 is equal to 46.7. Not the most beautiful number. And 4 divided by 60 times 100. That doesn't feel right. 4 divided by 60 times 100. It is right. 6.67%. Now, again, what I want us to do is add all these up. What should all of these added up equal again? Remind me, please. Yes, they should equal up 100. All your percentages should add up to be 100. So 20 plus 26.7 plus 46.7 plus 6.67 is equal to 100.07. Now, I know I said it should never go above or below 100, but honestly, in the grand scheme of things, 0.07% is a really small percentage, and we can handle that one. And if we rounded this out, we would end up maybe be the 7 out. We might have even ended up being closer. So I don't know. I would let it be personally, but it is what it is. Again, it's really, really close. My issue is when it's like 105 or 120 is not absolutely horrendous, or 92 or 65%. Those are not acceptable. I would say anywhere between 98 and 102 is about as far as you should go in terms of how far under or over your percentages and your percent composition. So the answer to all of this is that in this compound of CONH22, in all of it, 20% of the molecule is carbon, 26% of the molecule is oxygen, 46% of it is nitrogen, and only 6% of it's hydrogen, even though hydrogen had the most atoms. But it's because hydrogen is so, small. Yeah, so hydrogen's so small, so it actually is ever hard for it to accumulate very much percentage. All right, hopefully we're feeling okay with that one, because we did start off with getting the grams, and then we had to go find the grams using molar mass. Both are acceptable things to do, and I will need you to know how to do both. All right, ethane, something that might be a little easier to visualize other than the CO into NH2, because again, that's was kind of a nutso one. So let's start a little bit easier. Or let's start this one, which is a little bit easier. So again, carbon's molar mass is 12.0, while hydrogen's is 1.0. There are 2 carbons, though, while there are 6 hydrogens. So we're going to do that. We end up getting 24.0 grams per mole and 6.0 grams per mole for a total of 30 grams per mole. Now we're going to take that 30 and we're going to divide each of the pieces of the compound by 30 to see, and then multiply by 100 to see what the percent comp is. Because again, we're curious to know. There are way more hydrogens, but how much of the hydrogen actually makes up the compound? Because there are 6 of them, while there's only 2 carbons, but carbon weighs so much more. 12 times as more, actually. So let's do it. 24 divided by 30 is equal to 80%. Any guesses as to what the next answer will be? Yeah, my guess is 20% as well, but I'm going to go ahead and do the math just in case since we've already set it up. But 6.0 divided by 30 is 20%. Again, we crushed it. Also, Mr. Cotton, what are we doing with our significant figures? Good gracious. Now, this one would be 20.0, not 0, 20.0 decimal point, because this only has 2 sig figs, so our answer can only have 2 sig figs. We need that decimal or else the 0 will not be significant and we'll only have 1 sig fig. So we do need that decimal there, and then we do need the 0 after the decimal for carbon. So we are going to leave these exactly like this to double check our work. We can add these 2 percentages together, and it ends up equaling 100 exactly, which is goals. We are looking for that 100%. All right, so this one was a little bit easier than the last one. So hopefully this one gave you a good idea on how to like calmly, safely do a little bit of percent composition if you're not given the grams explicitly. You go find them on the periodic table. Okay, this one we're going to switch gears a little bit because it's not only asking us to find the percent composition, but it's saying how much of 22 grams of ethane is hydrogen. So now we're actually going to take our percentage that we did, and I could work through that problem again. I'll do a slight quick run through it, but 24.0 over 30.0 is equal to 80.0%. And then hydrogen's was, 6.0 over 30.0, giving us 20%. Okay, so this question is asking us if we have 20.2 grams of ethane, how much of this is carbon? So what we're going to say is, what we're going to do is 20.2 times the percentage. The issue is we can't just take 20.2 times 20. We've got to take it back out of the percentage. So it will be times 0.20. Because again, we only want 2 sig figs. I accidentally messed up and made it too many sig figs. There we go. Okie dokie. Okay, so we're going to take 20.2 times 0.2. So our total mass of grams times the percentage of our hydrogen, because I want to know how much hydrogen is in 20.2 grams of this specific compound. So 20.2 times 0.2 is going to give us 4.04 grams of hydrogen in the compound in 20.2 grams of the compound C2H6. Okay, so that, again, it's a little bit of switch. We're not just asking for percentages at this point. We're applying those percentages to an actual mass that we're given. So how much of that mass is hydrogen? We know 20% of ethane is hydrogen, and so we're going to apply that 20% to 20.2. I don't like that I use 20.2, so I do apologize for that. Maybe next year I'll change it to like 15, so it's not a very similar number. But yes, my point is we're taking the 20% times the mass of the substance that we're given. We do have one more problem like this, so hopefully if it didn't click there, it will now, because now we've got ammonium sulfide, or NH4,2S. But this time we want to know how much nitrogen is in this compound, but not just the percentage. We want to apply that percentage again to the mass of that compound we are given. Okay, so the first thing we want to do is find the percent comp of nitrogen in this. In order to do that, we need to know the molar mass of nitrogen, which is 14, but there is 2 of them because it is getting distributed through. So we're going to do 14.0 times 2, which is 28. And then we also need to know the total molar mass of ammonium sulfide. So we'll do that off to the side here. 28.0 grams per mole plus 8, because 2 times 4 is 8. And hydrogen's molar mass is 1.0, so 1.0 times 8 is 8 grams per mole. And then sulfur is 32 grams, 0.1 grams per mole, giving us a total of 68.1 grams per mole. So we're going to take that total, put 68.1 grams per mole as our total here. So we're going to do 28 divided by 68.1 grams per mole times 100, again, to get our percentage. And I'm going to take this down over here so it's out of the way. 28.0 divided by 68.1 times 100. So not surprisingly, the majority of it should be nitrogen because nitrogen is pretty heavy and there's 2 of them. Oof. So it is about 41.1%. And so we're going to take that percentage and apply it to, I'm going to take the percentage and apply it to the mass that we're given of the compound in real life. So it's like, okay, I'm literally sitting here with 82 grams of ammonium sulfide in my hands. How much of this is actually nitrogen? Well, we can again make that calculation based off the percent comp. So we're going to turn this percent back into a decimal, so 0.411. And then we're going to multiply it by the given mass that we have, again, just like sitting in our hands. Not really, hopefully, but could be. And we're going to end up getting, out of the 82 grams of ammonium sulfide, 33.7 grams of it is actually nitrogen, which is pretty cool. That's a good chunk of this compound that is actually nitrogen. Now, I know I did go through this pretty quickly. Hopefully you were working along with me and listening to what I had to say. It was, again, pretty quick and might have been a little rough. I'm hoping to smooth the little edges out when I do come back on Monday. So fingers crossed that I can help get that set up for you or smooth out for you. But if hopefully I don't have to. Hopefully this video was instructive enough and you guys are ready to roll and move on when I get back tomorrow, because this should be what you're working on Monday. I am making 2 videos. This is the second video. And I'm hoping that you guys listen to both and are prepared for me to come back, because I am going to move through this quickly, whether you watched it or not, because it should be something you're doing in class. Both videos should be less than 51 minutes easily, so I don't see a reason why we shouldn't have it done. And in fact, I might have some practice problems assigned in Google Classroom as well, just to see if you know what you're doing and or can figure something out while I'm gone. You could try and cheat the system maybe on these problems, but it might not be in your benefit, because if I think you're doing well, I won't spend as much time on it. And then you won't be able to potentially fix any wrinkles that you may have. Now, that being said, if you don't have any wrinkles, that's awesome. That's what we're looking for. But yeah, again, hope it's not been too crazy while I've been gone, and I'm excited to be back and see you guys all tomorrow. But yes, again, I will be back tomorrow. Have an excellent evening or a good rest of your day, depending on what time it is. I'm recording this in the evening, so evening. And yeah, have a good one. Bye.